Hello everyone, welcome to Math Wonders. For today, we are going to tackle about theorem on limits for grade 10 mathematics, starting with the theorem number 1. So theorem number 1 states that the limit of c as x approaches a is equals to c, where c is a constant number. For you to understand it better, I have here some examples. Example number 1, limit of 4 as x approaches 2 is equals to 4, because 4 is the constant number. For example number 2, the limit of 7 as x approaches 1 is still equals to 7, because 7 is the constant number. The answer to this is just equivalent to the constant number of the given problem. So next is our theorem number 2. Theorem number 2 states that for any number a, the limit of x as x approaches a is equals to a. For example, let's try this problem. The limit of x as x approaches 8 is equals to 8, because 8 is the value of x. Next, the limit of x as x approaches 4 is equals to 4. See, it's that easy.
I will be discussing to you today on how to solve the Theorem 3 on limits or the sum and difference rule. Suppose limit of f of x is equals to a as x approaches a, and limit of g of x is equals to b as x approaches a. Then we have the limit of the quantity of f of x plus g of x as x approaches a is equals to a plus b. Or we have the limit of quantity of f of x minus g of x as x approaches a is equals to a minus b. We have the sum and the difference. To illustrate our theorem 3, let's have our examples. Let's first apply our addition rule. Let's say we have limit of 3x plus 6 as x approaches 1. According to our rule, this can be written as limit of 3x as x approaches 1 plus limit of 6 as x approaches 1. We are going to separate them. Next, get the constant, which is 3, times x approaches 1, substitute x, which is 1, plus our constant 6 will remain as is. Now, let's solve it. 3 times 1 is equals to 3, plus 6, then it is equal to 9. Now we'll be using the difference rule. Let's say we have limit of 4x minus 2 as x approaches negative 2. Applying our theorem, that is equal to limit of 4x as x approaches negative 2 minus limit of 2 as x approaches negative 2. Now we're just going to do the same procedure as the first example, but we'll be using subtraction instead. We have 4 times x approaches negative 2, substitute x, which is negative 2, minus our constant 2 will remain. 4 times negative 2 is equals to negative 8, minus 2, and that is equal to negative 10. And that is theorem 3.
Now let's have our theorem number 4, which is the product rule. So suppose that the limit of f of x as x approaches a equals L, and limit of g of x as x approaches a equals m. Then, the limit of f of x times g of x as x approaches a equals L times m. So we have the limit of x times 3x plus 1 as x approaches 2. We will multiply our first function to the second function. So we have that is equal to the limit of x as x approaches 2 times the limit of 3x plus 1 as x approaches 2. Theorem 2, limit of x as x approaches 2, that is simply 2. Times, by using theorem 4, the constant 3. Times the limit of x as x approaches 2. Limit of x as x approaches 2 plus the limit of 1 as x approaches 2. Now 2 times 3 times applying theorem 2, that will become 2 plus 1. Now we have 2 times 3, that is 6 plus 1. Now 2 times 7, because of this 6 plus 1. Now 2 times 7 is equals to 14, and 14 is our final answer.
Hello everyone, today I will be teaching you all about Theorem 7 on our topic, limits of function. Theorem 7 states that limit of 1 over x raised to the power of r as x approaches a will always equal to 0. Let us try using it in a problem. This is the example. Limit of 1 minus 4 over x plus 3 over x squared divided by 2 plus 5 over x squared as x approaches infinity. By Theorem 7, 4 over x, 3 over x squared, and 5 over x squared will automatically become 0. Therefore, if we cancel out 4 over x, 3 over x squared, and 5 over x squared, the answer will be 1 and 2, or 1/2. Why, you may ask? Because like said, any number that has a denominator with or without exponent will always equal to 0. That concludes our lesson for Theorem number 7.
I'm just calling to say I
am so troubled by the soul of mine. I've said those words so many times. I need you in this life. I need you in this life.
oh Nadine, I have different audio. Oh yeah. Oh, this
I am so troubled by the soul of
Hey, we're on a budget, right? Just studying limits.
Now,
Okay.